Yes. So see, uh, these are the outline of this lecture. And first, we are going to discuss about the relation between IoT and neurorobotics, and then we will basically start that what is neurorobotics and what are the different models of neurorobotics, their implication, and then we will discuss about one Darwin robot series, that is basically a example of your neuro robots, and at last we will discuss the role of neural network in this entire scenario. So see, as you already know about the definition, the architecture, and the other thing related to IoT. So the your field of Internet of Things, and if we are especially talking about the industrial IoT, that so from several years, one more name is given to or abbreviation is given to this field. IIoT means Industrial Internet of Things, and the development is very rapid in the field of industrial application of IoT. Okay, and here the things can range from a simple RFID device that we are adding to the IoT network, or a intelligent wireless sensor and actuators, or it is a type of robot that we are connecting with the help of IoT, or a type of autonomous vehicles. So this is, we can consider a type of range or variety of devices or variety of things that we can add into the IoT. Okay, so these new application is basically more oriented toward the autonomous type of system, the system which are capable of taking the decision by their own. Okay, because as you can see, the autonomous vehicles are there, and the normal robots are there, and some intelligent wireless sensor networks are also there inside the IoT. So more or less, these are type of autonomous system, which are uh, have a capability to take the decisions. So this will lead to a specific name, Internet of Robotic Things, and the abbreviation given is IORT, Internet of Robotics Things. And this robotics is simply a representing the system, which is a type of autonomous system, and that system is able to take decision by its own. So in this picture, you can see uh, various fields are given and that are associated with your IORT, Internet of Robotic Things. So here you can see electrical engineering is involved, software engineering is involved, computer science is there, field of mathematics is there, material science is there, and if we are talking or taking the help of some database, so like your law database is there, and mechanical engineering is there, and something we are taking the inspiration from the biology, or if we are considering the example of human brain, so your artificial intelligence and the development of artificial intelligence are motivated from the human brain working only, so role of biology is there, and if somebody have the knowledge of this swarm based intelligence, so that is also taken from the your physical world, means how animals, birds, and other living organisms are following some strategy for their survival. So if they are means we are mimicking the same type of process, for some algorithm, or some procedure, so we can say that this particular algorithm is inspired from the uh, biological animals. Okay, so physics is also involved, and if more specifically we can focus on this psychology and cognitive science. Okay, so these are the two or three you can say areas which will build the base for your neuro robotics. Psychology means how humans are behaving. So what type of facility we are providing when we are dealing with the topics like human machine interaction, human machine interface, and or the behaviors of human. Okay, and this cognitive science is the area which basically deal with the cognitive models, cognitive process, and decision process. So, this your psychology, cognitive science, and artificial intelligence. These are very closely related to each other. Because first we have to understand the psychology of human. That how humans or the user that is utilizing the capability of IoT will take decision. So that we have to analyze, and this analysis we can perform with the help of cognitive science. This cognitive science is a field in which uh, we can try to build or understand a cognitive process that is going in our mind, that how we are taking the decision, how we are evaluating the situations, and how we are searching for the possible option, means what option are there for taking the decision. So all this called the cognitive process, and based on that we are able to develop some artificial intelligence algorithms. And so that algorithm we will put inside the robot, and then we will connect that robot to the this IORT system, or IORT network. So then that robot, which is having the a human-like behavior and have certain amount of cognitive ability to take decision, and so this will means that robot will take the decision in this IORT. Okay, so this is your a simple visualization or the associative field inside the Internet of Robotic Things. Okay, now if we will read a simple definition of your Internet of Robotic Thing. So it is a collaborative robotic things that can communicate to each other. Means this we can consider as one of the features that these robots are able to communicate with each other. Because generally in that IoT network, humans are there, machines are there, and many sensors are there, actuators are there, and they are continuously transmitting the data from one end to another. So in this some means several robots are there, and they are also able to communicate with each other, and means it is a type, you can say, machine to machine interaction is also there, and one human to machine interaction is there, in which one end human is there and at other end machine is there. But this is a type of case where machine to machine is communication is there, means one robot is sending the data and another robot will receive it, explode that data, take some decision, and send back to the first robot. It has the capability of learn autonomously, means based on the situation and or the condition that the robot will face. So according to that, it will learn. And like in this situation, what type of decision he has to take. Then interact safely with the environment, human and other things. And he also knows the rules about that how we have to reply to the humans, or how we have to reply to the other things. And means see, it is not like a case that all the robots are connected to that network, and humans are also connected, and some other devices are also connected. So he is able to differentiate between which is the a human body, which is the some other kind of device, and which is the similar kind of robot. So how to interact with each other and without damaging the environment. And this gain qualities like self maintenance, self awareness, self healing, and fail operational behavior. Means during this you can say learning process, he is able to gain the qualities like self maintenance means how the robot is able to maintain itself. Then self awareness means simply the gathering the information about itself. Self feeling, if during this self maintenance on awareness he finds some mistake that some of the component is not working properly, or he is not able to receive the proper message, so how to recover from that condition. And if he is not able to recover, then a fail condition is there, so how to operate in fail, or how to inform other that I am not able to work properly, so other will take some decision. So if all the qualities are there inside the your robot, so we can say it is a type of autonomous robot, or we can say it is a type of neuro robot. Basically, see, neuro robot is a separate field, and IoT is separate field. But nowadays, more autonomous system are in trend. We are you can say shifting from a network which is having the more human user, rather than we are shifting to this in a scenario where only robot will take the decision. Okay, so that's why the requirement of neuro robots are more. Okay, now little bit we will see what are the different application areas and where we can apply this IoRT. So according to the environment, and it is classified. So industrial robotics is there, field robotics is there, and service robotics is there. So you can see further we will explore the industrial robotics. So these are several cases where we can use this IoRT, like on assembly line, fault finding, painting, welding, and delivery of items. So these are the cases in which we can use this IoRT inside the industrial environment. And in this field environment means it is related to, you can say, a outdoor activity that in which your robotics is involved, like the monitoring of agriculture, construction, road work, mining, and other logistics. So it is related to the field work. Then your service is related to, like, you are utilizing this IoRT in banking system or in transportation system, tourism, healthcare, or in a home environment. Okay, so based on this, we have to identify which type of robot is required, and so accordingly we have to give the intelligence or ability of cognitive science to that particular robot. Because means till now means robots are not intelligent as humans, so they are not having the vast knowledge about this. A normal human can easily differentiate between these three fields, and accordingly he has to take the decision. But for the robot, it is a, you can say, limited set of information is there, and so according to field we have to give some knowledge, and further knowledge he will build during the learning process. Okay, now these are the functional block inside the IoRT. Okay, so again, and if I will read, so many uh, blocks are there, and like a blocks which is related to the perception and sensing. Okay, a block related to the processing, and so here we have to deal with the energy, speed, and a code size and all these things. Then the our main focus is on your cognition and intelligence, then planning, and then decision and control. Okay, so these are the few things that will play a role in neurorobotics. Because see, cognition and intelligence, it has to deal with the information, combination of information, and developing collective intelligence and collective cognition. Means, see, the means of collection is your perception and sensing, like different kind of sensors are there, and from these sensors we are collecting the information, and then we have to process this information. and after processing we have to make some plan of action, like what is the extract of this particular information. According to that we have to perform some operation. Okay, and this decision and control is nothing like means once we are done with the planning, like we have explored the several options, and according to that we have to take the decision. Okay, and these other fields are also there, but these blocks are you can say common to other IoTs also, like related to connectivity, data storage, and other things. Okay. So see, as we have discussed, means in present day IoT there is a requirement of autonomous robotics, or we can say a neuro robotics. So this autonomous robotic system is nothing but a means which is capable to do these things, like I will read the point wise. So operate more seamlessly within the human environment. Then for this they must integrate technologies providing sensing, say senses like sight, hearing, taste, smell, and touch. So you can see these are the properties, or you can say a type of senses which a human can easily feel. Okay, but it is a type of means it is a difficult task that how we are able to provide these type of senses to a robot. So that is the, you can say, a challenge or the problem in this particular field. Like sight, hearing, this we can easily provide to a robot. By installing a camera, we can give the sight to the robot, or by providing the mic, or the earphone, or the sound sensor, and we are able to give the properties a hearing. But what about the taste? What about the smell? Okay, smell sensors are also there, and means gas sensors are also there. So this we can use. And what about the touch? So how to means add these senses to the robot so it will more act like a human. And so your IoT devices can better operate with humans, and humans can better interact with the digital, virtual, and cyber world. And this is the a type of, you can say, objective of this autonomous robotic system. And by providing these things, means these senses to robot, it will more likely to act as a human, and so human will also get same feel, that a system with the human is interacting, and you will feel it is a similar kind of uh, means human is there. If he is not able to recognize whether a robot is replying or some human is replying. Okay. So I think now it is clear that why we are basically discussing this topic of neuro robotics, because in future there are means a huge requirement of neuro robots in the IoT scenario. Okay. So from this point, and now we will discuss about the basic of neuro robot. So you can see a simple definition like neuro robots are the robot whose control has been inspired model similar to the some aspect of human brain. And means basically we are taking the idea or the model from the human brain, and how human brain is receiving the information, processing the information, and take the decision. And so that we have to explore to create a neuro robot, because more or less neuro robotics is a separate field of robotics. While in normal field we can design a robot that may have limbs, or a similar face like a human, but how to give a working brain to that robot, so he can take the decision by its own. So this is the core part of your neuro robot. Okay, so here is some introductory point about the neurorobotics. So neurorobotics is a combined study of neuroscience, robotic, and artificial intelligence. And as in first slide also we have seen, robotics is required, and this neuroscience is nothing, that is the, you can say, superset of your cognitive process in psychology. So neuroscience is there, and robotics is there, and artificial intelligence is there. So it is the science and technology of embedded autonomous neural system. Okay, so if you know about the neural system, means how the humans are executing their daily routine works, and so with the help of their neural system, and a brain is passing the commands and or the information to the various part of the body, and accordingly we are able to move the body, and operate in an environment. Then your neural system includes brain inspired algorithms and computational model of biological neural network. Okay, this we have, I think all know, and your biological neural network is the inspiration of your artificial neural network also. So many of the computational model are nothing but taking the inspiration from the biological networks only. Okay, and such network system can be embedded in machine with mechanic or any other forms of physical actuation. Okay, so this system and a neural system we had to add to the your robot, and so he is able to perform the either in the form of mechanical and or in the form of some decision making task. Okay, so these are the some example, and these include either we are able to build the robot, prosthesis, and or wearable systems. And so this point become clear on the next slide. Okay. So here you can see two main approaches are there, and by which we can design a neuro robot. First is the neuroscience, and second is the artificial intelligence. So in neuroscience, we attempt to recognize what intelligence consists and how it works by investigating intelligent biological system. So this point we have already discussed, like what is the role of your neuroscience and a cognitive process and or the psychology. Because first we have to define what is the meaning of intelligence, and then only we are able to develop some algorithm, or procedure that we can write in the form of computer program, and then it will execute in the robot and or in the IoT scenario. So in neuroscience, and I mean the person that are related to the field of neuroscience, they will explore that how we can define the intelligence and how it works and how humans are taking the decision. And after that, your artificial intelligence. This is the study of artificial intelligence, attempt to recreate the intelligence, through non-biological or artificial means. Means once you get the idea how to define intelligence and or what is the intelligence, then we are able to create some artificial mechanism to mimic the same thing, means recreating the intelligence. So two approaches are there. So generally the person that are from the biological or sciences background, they will focus on neuroscience part, and the person which are from the computer science or electronics background, they are focused on the this artificial intelligence part. Okay, now there are several type of model by which we can design a neuro robotic a neuro robot, so these are 4 neuro robotic model that we can work on. So you can see first one is locomotion and motor control. Second one is learning and memory system. Third one is action selection and value system, and fourth one is sensory perception. So if you will see, all these are more or less properties of any human, and how we will discuss one by one, like locomotion and motor control. And with this is the property related to how humans are able to walk. And means if we can differentiate human from an animal, and an animal need four limbs to walk, and though human can walk only on 2 feet. So this is a type of, you can say, a locomotion, or the motor control that is only with humans. So he is easily able to run, walk, or do any kind of activity with his limbs. So this is about the motor control. And so more or less same type of mechanism we have to introduce inside a robot. So he is easily able to walk and run. Then second is learning and memory system. So again, this is a property of human, and how humans are learning by their day-by-day experience, and how they are storing their memories, good memories, bad memories, and good decision, bad decision. So learning also they are doing at same time, and same time they are also creating the memories. Then third one is action selection and value system. So your action selection and value system is basically related to it is a kind of, you can say, ethics in the human beings. And it means according to the situation, what decision we have to take. Okay, like say if we have to take decision that will affect the you can say a specific population. So we have to think many times that if we will take good decision or bad decision, so how it will affect the other human beings. So a means in a ethical way we have to think, and we have to analyze before taking the decision, and whether this decision is beneficial to the other human beings, or dangerous to the other human beings. So this point is related to that thing, action selection and value system. So based on some value we have to take the action. And last one is the sensory and perception. And so this is just related to, like, we are able to see, we are able to feel the touch, and a sensation is there, and hearing capacity is there. And so all these are the type of sensation. So how we are able to provide this to a robot. And so in general, your hearing capacity and vision capacity capability we can easily give to the robot, but other type of sensors are difficult to uh, means install, or we are able to means we will face difficulty to build the different kind of sensory similar to the humans, like feel of touch, and your smell, or the taste. So these are means you can say under progress, means the researcher are working on these sensory perception also. Okay. So now one by one we can take a one example, of each four type, so you will get a little bit more insight of these four models. Okay, so first one is locomotion and motor control. So here, as we have discussed, these mimicked from the locomotion of human or animals, and it means we are providing the capabilities to a robot, that how humans are walking, or how animals are walking, so they are also able to walk or run in the same pattern. Then one model for central pattern generator is there. Okay, this we will just explore in the next slide. What is this central pattern generator? So Here you can see bunch of neurons capable of driving respective behavior like walking or rowing. Okay, so see this bunch of neurons means if we will consider an entire brain, so in entire brain a specific portion is there, or a specific lobe is there which is responsible for this walking behavior. Means any type of activity that we are performing with our limbs, or hands. So a specific neurons in the brain are controlling that activity, and these neurons are generating the signals, which are known as this central pattern generator. And if you will focus on a walking pattern, and so it is a continuous type of cycle, continuous type of mechanism, and how we can lift one leg in the air, shift the position and put on the floor, and then we have to uh, shift the other leg, so it is a type of continuous process, so this is basically done with the help of the central pattern generator. So here you can see this is a little, you can say, biology and how this your locomotion and motor control work. So as we know, the brain is controlling the entire body movement. So you can see this central pattern generator is there, and what type of commands and or signal this CPG is giving to the muscles of the leg. Okay. So it is a type of flex and relax type of action, and so our leg will move, and so one time we have to do flex and one time we have to do relax. So continuously a type of signal is there, and so accordingly we are able to run or walk. Okay, so signal comes according to our muscle will respond. Okay, so this, if we are able to model in the form of some computer program, and with what speed we have to run or with what speed we have to walk, and so if we are able to design some algorithm or the model, and that model is installed or put it inside uh, the limb system of the robot, and so he is also able to walk in the similar pattern. Okay, so this is the role of the central pattern generator. Okay, now the second thing, the learning and memory system. So see, it is nothing but the model of hippocampus, and it is a part of brain, that remembers the location. Okay, means memories or the information related to the locations, means some landmark is there, or our address is there. All these things are stored in the this hippocampus location. Okay, so this is also modeled, so your robot will able to uh, remember the geographical locations, or the places that he has visited. And for this, nowadays researchers are using the rat hippocampus, means uh, the they are studying how the hippocampus of rat is working, and because uh, rat have a large or a rich hippocampus area, and rats are also continuously visiting from one place to another in the search of food, but they will well remember that on which particular location they will get the food, so entire, you can say, a map is stored in their hippocampus area. So that's why the researcher are taking the help of the rat hippocampus. So and they are developing a model, that is able to learn the mental maps. These mental maps are nothing but the how well any person or a animal is able to store uh, the pathway, and or the different location inside their brain. Okay, which also include the recognition of the landmarks, means previous places that we have visited, and this help to predict the upcoming obstacle and yes, upcoming obstacles and other landmark also. Okay, so this will little bit become clear, and on this slide, see here you can see uh, it is one experiment, and this is a just a type of visualization of that experiment. And so one you can say rat is there, okay, and is present inside a type of mesh. So multiple paths is there, and so he has to take out from this mesh. So at the same time, and if you can see on the other image, and one red is there, okay, and two screen are there, and blue screen and red screen are there. So the researchers, and they want to take and how these rats are taking the decisions. And so it is a type of experiment like on the blue screen, if red goes, so he will get food. And in near to the red screen, if the robot goes, so there is no food. And so how he is able to remember and or link this information inside the brain. And so at the same time, we are making the recording of the brain signals also. Okay, so this is the type of experiment, and after the this lecture, and I will also explore a website where you will get this complete information also, and that what is this experiment and what the platform they are using. And but I think you are getting the idea, and that we can develop a model for learning and memory system, based on the real experiment, and we are taking the subject as a rat. So it is the initial level of the research, so that's why it is a difficult, and not allowed to directly work with the human. Okay, now third one is the action selection and value system. So here you can see in a biological system, neurotransmitters such as the dopamine, positive reinforce neural signal that are beneficial. Means uh, how humans are motivated and or influenced to take some decision, and this is done basically with the help of this neurotransmitter, and the chemical that is known as the dopamine. And so see if you are doing any task, and if you will feel good and after completing that task, so a signal is given to the brain, and that in future also if the task come, then we have to complete that task. Okay, and in other case, if the task is not beneficial to us, or we are getting any harm from that task, so again the some other kind of neurotransmitter is there, that will oppose that task and or the decision in future. So it is a type of, you can say, uh, positive and negative reward kind of thing. And so this thing we can also include inside a robot. And so positive reward is used as neural signal having the beneficial output of result. And it means if robot has taken some decision, so we have to give the positive reward. So it will increase the probability of that decision, and when he has to take uh, uh, the the same type of decision for some other task. And so this type of facility we can make inside the robot by adding this facility of positive or negative reward. And so it is a type of, we are providing some uh, value system to perform the action. Okay, here is one more example and that is related to the a simulated taste. And as previously we have discussed that how to give a sense of smell or give a sense of taste. And so this is a one example, and in which some researcher has uh, done a experimental work to simulate the taste for robot. And so they are using a metal block as a food, okay, and the taste is simulated by the conductivity of that metal. Okay, so if good conductive metal is there, so the command is given like it is a good taste, and if bad conductivity metal is there, so the command given as the bad taste. Means you can see up to what level they are thinking that how to simulate a taste for a robot. And so as we all know, the uh, means there is no use of food for the robot. Robot will only work on the their means batteries and some other source of energy. But anyhow, according to the condition or according to the need, if we have to give the taste to the robot, so they have initially taken that like we are giving the a metal piece to the robot to eat, and so based on the conductivity, they will able to recognize whether it is a good taste metal or a bad taste metal. Okay, and the robot has positive negative feedback to the taste based on the level of conductivity. Means if conductivity is very much good, so very good taste is there, and conductivity is bad, so bad taste or it is less in taste. Okay, so by this also we can means you can also think of some new idea and to provide the a different type of senses to the robot, means similar to the humans. Okay, now uh, one more experiment is there that is related to the action selection and value system. So neuro robot can also be learned on simple ethical interaction. Okay, so as we have discussed that humans are easily ethically evaluate any condition, and because they know that how other humans are feel when they will take decision, and so on some ethical background also they have to take the evaluation of that condition. Okay, so one classical thought experiment is there. In this, what is the case? One boat is there, and on that boat several human beings are there, and one robot is there. So how robot is able to recognize to save the life of other people's, and he has to jump into the water, and the condition is like that their boat is not able to hold the weight of all the person and robots. So means he has to know the situation that if I will jump from the boat, so humans can create a new robot, but if some other person dies, so we are not able to recover the life of that person. So this is a type of ethic that we have to provide inside the robot. Means a life of robot uh, can be easily recovered by creating a new robot, but a life of a human being cannot be recovered. Okay, so this is a type of action selection and value system. Okay, now the last one is sensory perception. Okay, so in this you can see sense of depth, distance, and speed. Okay, these sensor a human can easily feel. And see if some car goes in front of us, and just by looking it, we are able to guess that what is the speed and or at what distance that car is, and either it is going away from us and or coming near to us. So just by looking, we are able to sense the distance and speed. And looking in hit any hole or something, we are also able to sense the depth. Okay, so see the for the example, the depth information may change due to the human head or eye movement. This is just about the from which angle we are seeing any object. So according to that, distance and speed may vary. Okay. So to establish robust representation of the visual sense, because how we can train a robot, that if you are not getting a proper information for from a the angle means at from present angle, so how he is able to shift the camera to take the different look of that or the different sense of that object, to recognize the object or the feel the distance and speed of that object. So this type of mechanism we have to also build inside the robot. So here you can see by these images, you can see or understand that how they are making the experiments. So like they are taking one ball and giving the instruction to the robot to uh, trace that trace the location of that ball, and that human is continuously shifting or adjusting the position of that ball, and according to that, the means continuously moving object, that is here written as target, and it may be the ball or some other other shape object is there. Okay, so how this robot will coordinate the continuous movement of this object, and if he has to hold that continuously moving object, so how he has to make the coordination between the movement of that object and the movement of his arm. Okay, so this is a kind of a real sensory perception. Okay, so see, up to this, we have discussed the 4 different model of neurorobotics, and where this neurorobotic play a role, that we have also seen in the initial slide, the example of IURT. And so up to this point, if somebody asks, or somebody want to discuss something, then please ask. And because after this, we are starting the you can say different portion, the implementation and some examples. Any type of question, or something that you want to discuss. Okay, in chat somebody has written, okay, about the camera. Okay, I will stop the camera. Okay.
Sir, I would like to ask a question. So
Yes.
kindly tell us about the central pattern generator. Actually, sir, in my research, I am doing some work related to easy control of human locomotion, but I don't know so much about central pattern generator of brain.
Okay. Your good name?
I am the organizer itself, Vishwanath, sir.
Okay, okay, sir. Sorry, sir.
Yes,
Sir,
no
see,
problem, sir.
okay, okay. See, sir, this is the a type of a concept. See, like in the brain, means brain is coordinating all the things. Whether we have to move the position of arm, and or we have to walk, run, and or whatever type of activity we have to perform. All the things are coordinated by this the brain only. Okay. So brain is further divided into several lobes also. Okay, and some of the lobes are related to memory, some are related to motor control, and some are related to you can say uh, decision making, or information. So these different responsibilities are allocated to each and every part of the brain. And after means at the end part of this your brain, and we can call this as a mini brain or a hind limb also, hind brain also, and this small portion.
Yes, sir.
So inside this portion, because this portion is directly connected to our spinal cord, and inside the spinal cord many nerves are there. So basically what happened, a routine type of work that we already learn, a routine type of work that we already learned, like a small child is not able to properly walk, but after few years he can easily walk and run. So a routine type of work, the responsibility is given to this part only, because see sometimes you can also see like you are thinking of some other thing, and while you are walking, and means like you are go for the evening walk and you are continuously thinking of some other thing, and like some memories of college or something, and you are not able to put the focus on the walking, and so that pattern is automatically generated, and because the brain is learned, and for a time he is just giving the command to this a small brain that you have to coordinate with the body motion, and the brain is itself engaged in some other task, and doing some processing, or recalling some memory or doing something else. Okay, so this
Yes.
central pattern generation is the same type, we can say a type of continuous signal that this brain is giving to the this nervous system, means
Yes,
inside
sir.
the spine.
Yes.
So it is a type of, you can say, cycle.
Yes, sir. Yes.
Okay, when to flex and when to relax the muscle.
Okay.
So
Yes, sir.
if the frequency of cycle is very high, means we can say that the person is running, because in a very short duration we are flexing and relaxing the muscles, and if we
Yes, sir.
want very slow walk, so it is just like a you can say the cycle of less frequency.
Yes, sir. Yes.
Okay, so this is the case,
Yes.
with this.
Sir, one more question, sir. This is my
Yes,
personal question related to my research. Actually,
yes, yes.
sir, I want to analyze the alpha waves of brain
Okay,
during but sir, sometimes some researchers said that ki alpha waves are correct when you are in sleep position. Actually, sir, I have 32 point EEG machine in my lab.
okay,
So I want to analyze, but sir, actually, sir, I want to analyze the locomotion with the help of alpha waves. So some researchers are saying that ki alpha waves are
okay. Sir, the
you get
classification is like that. Like, okay, so 0 to 4 hertz, then 4 to I think 8 hertz, and 8 to 13, and 13 to say 30 or 35 hertz, we can say. Okay,
yes, sir.
so delta, theta,
Yes.
alpha, and beta, and I think this is the classification
Yes,
of
sir. Yes,
delta,
sir. This
theta,
is
alpha.
yes, sir. Yes.
So see this your delta and theta, these waves are generated when we are sleeping, or when we are in the very relaxing mode.
Relax position. Yes.
Yes, and alpha and beta are the active cases, when person is fully awake, and these are the means a type of fluctuation that we will get in the EEG signal, and means these type of frequency are there when we are
Yes.
performing any kind of activity, and so that's why whenever we will take some database, so we are able to discard these frequencies, means delta and
Yes, sir.
theta. We have to only work with alpha and beta waves.
Alpha and beta.
And,
Okay, sir.
and it may vary person to person, because see, these walking and activity we can also perform just after the sleep.
Yes, sir.
So,
Yes.
and a little alpha wave is there, and once we are fully awake, so then the beta waves.
Beta wave. Yes, sir. Yes. Thank you, sir.
Okay, sir.
Any
So,
participant wants to ask any question?
Sir,
yes.
sir, I have a question. I don't know if it is relevant to this topic or not. Sir, just you have told the alpha and beta signals are there in our brain when we are
Yes.
working hard. And about the delta and theta,
Yes.
actually recently I was running for one of my relative. Some
Yes.
of one doctor told ki there are the theta signals are there in his brain at
Yes.
the time of sleeping. So it is a
Yes.
tendency of epilepsy or like that. So from the engineering point of view, you are telling the delta and theta signals, those can be avoided. Is that like that?
See, like sir has asked, he has to take the data or analyze the data when person is awake and walking. So see,
Hmm.
it is a type of means a very common information, and that is given in the field of EEG, like
Hmm.
low frequency signal. Low frequency signal means we can consider 0 to 4 or 4 to 8. So these low frequency signal are generated when the person is in sleep or in drowsy state. Means a state of rest no thinking. And sleep, if we are especially talking about the sleep EEG. Okay, so
Hmm.
sleep
Yes.
good when we are getting the low frequency signal. So generally we will prefer the delta wave only, 4 to 0. But during the sleep, if some activity is there, means
Hmm.
during the sleep, if some activity is there, means we can say inside the sleep, a person is not relaxed. Means there is some continuous activity going inside the brain, though the body is relaxed, but brain is
Okay.
not.
Okay.
This may be the case, means due to epilepsy or due to something, means their brain is continuously working.
Okay. Okay.
And
Thank
when your,
you.
your body and brain both are fully awake, so then there's this case of 18 to 13 or 13 to 35 hertz is there.
Okay. Okay. Thank you, sir.
Okay. Okay, so where we have discussed, and so now we have to discuss some implication of this neuroscience field. So see, this neurorobotics is beneficial for neuroscientists. Why? Because it provides a platform to test various methods of brain function in controlled and testable environment. So see, this is you can say more or less same point, and I just we are having the discussion, like say some patient is there, and doctors are not able to test different type of test condition over the brain, because see we cannot means we have to take very seriously any patient. So if we want to perform different kind of test or evaluate different kind of test over a brain, so it is a better that first we can create a model of brain, and over that model we can do many things. So there is no risk as means that are related to some patient or the real case. So this is you can say the advantage with this type of neuro robotics also, that we can develop a artificial functionality of brain, and that functionality we can evaluate or simulate in the form of computer program only. And if the results are good, then we can do that thing with the live brain, or the brain of some patient. Okay, then the robot are simplified version of the system that they emulate. They are more specific, allowing more direct testing. So this is more or less same type of thing that we have discussed. They also have to benefit of being accessible at all time. Means if there is again the availability of the patient or the human for the research, but if we are able to develop a brain according to the need, so anytime we can do the testing, and any number of time we can do the test. Well, this will also beneficial in case of your neural rehabilitation. Okay, so the process is dependent on the underworking of the brain and how exactly it works. Okay, so I think some of you have the idea about the uh, rehabilitation, or the neural rehabilitation means it is a type of field, when body parts are properly working, but there is some damage or misconnection between the nervous system. So the messages or the command that are given by the brain are not properly reaching for the body parts. So this we can also trace within the brain, that where that mishappening is there. So we are able to solve that. This we can also do. Okay, now we will see some example of your Darwin robot series. So these are the very first robot that we can call as the neuro robot, or the example of neuro robot. And they are also known as the brain-based devices. Okay, so here we will see some of the images of these robots. So as you can see, these series started in early 90s, 92 to 1998. So here you can see only a, you can say, a device like robot is there, and it is not a fully humanoid robot, and which has the arms and legs, and they are more focusing about the different kind of sensing property of the robot. Means how well the robot is able to sense the environment. So if he is having the good sensing capabilities of environment, so he can take the good decisions. So here you can see a different microphone or audio sensors are there, camera is there, and further in the advanced version, you can also see a type of these spikes are also there. Okay, so by this, they are able to sense the means feel of touch. Like the one thing is that we can simply use the camera to find out the obstacle, but they will also able to feel the you can say feel of your floor, whether the floor is wet or dry. So this we can sense with the help of these spikes. So again means you can say advanced type of sensing we are providing to the robot. Okay, so in this manner continuously they are making the improvement in this Darwin series. Okay, and the basic principle of working of Darwin series is the neural network, means they have a learning system. Okay, and if I think many of you have also the idea of artificial neural network. So this artificial neural network consists of the neurons and hidden layers, input layer, output layer, having the different type of means different numbers of neurons. So they are talking about same neurons. So around 20,000 neurons are there, and their connection are around 5 lakhs connection are there. So they are taking the input, processing the information, and then taking the decision. Okay, after this, this is the fifth, sixth, seventh Darwin robot, and in 10th Darwin robot, you can see 1 lakh neurons is there and 1.5 million synapses is there. So you can see a high computation is required, and they are able to develop hippocampus inside the robot. Okay, so to implement the hippocampus, they are using this much amount of neurons to create a artificial neural network. So it will learn and take the decision. Okay. Now these are the some you can say advanced type of researchers and researches which are taking the combination of evolutionary algorithm and artificial neural network algorithm. So this is just about that how neural network is working and how evolutionary algorithm is working to evaluate the different condition and take the decision. Okay, but we are not going much inside of this. Okay, so nowadays, and you can see the trend of deep learning is there. So deep neural network are also used to learn the concept of provide the learning for the neuro robotics. Okay, and your restricted Boltzmann machine is also used to provide the context of sense, and this context of sense means the identification of object. So as in the starting, we have seen a different classification of IURT, whether your IURT is for field or IURT or is for some industrial purpose or for the home applications. And so how your robot is able to identify the context of sense. So whether he is placed in some office, whether he is placed in some kitchen or restroom. So accordingly, he have to judge the object. Because in office we are having the different set of object. In kitchen we are having the different set of object. So how is that robot is able to identify the environment? Okay, so again, deep belief neural networks are also used for providing a grasping power. And so that example we have seen, one person is shifting position of ball in front of robot. So how robot is able to grasp that continuously moving ball. And so these all things are achievable by lots of training, and this lots of training is simply done by the deep neural network or artificial neural network. Okay, and these are some property of neuro-robotic device. Already these are same that we have discussed. It is it engaged in a behavioral task. Means like we are well aware of the behavior of humans, so same kind of behavior you have to also build inside the robot. It is a situational, situated in a structured environment, and if the robot is able to identify whether he is placed in the office or he is placed in the kitchen or in some other kind of environment. So while looking the object or object recognition, he is able to identify the environment. Okay, its behavior is controlled by a simulated nervous system that we have developed, having a design that reflect at some level the brain architecture and dynamics. Means the inspiration of the model that is working inside the neuron node is somehow related to the brain architecture. Whether it is for locomotion control or for the uh, action selection and value system or for the memory or learning system. Okay, and these are some of the key feature. of the brain, learning by rewiring, and means every time when we are facing a new situation and or doing a new task, so our brain is connected in some different way, and means from one loop to another loop, new connections are created. And your embodiments means sensory motor integration is observed through an intelligent system, means the intelligence that we are providing inside the neuro robot. Then value system we have already discussed, and prediction is nothing but the means how we are utilizing the past experience to take the decision in future. And these are the some of the references. Basically two main references are there from where I have taken all the materials, images and pictures. So you may follow that. And still, if somebody wants to discuss something, then please discuss. Okay, and meanwhile, I will show a just give me 1 minute. I will show a neuro robotic platform, where all the detailed experiments are given. So, are you able to see the screen of web browser?
Yes, sir. Yes, sir. It is visible.
Okay. So, see, you will simply explore this website. This is eBrains Neuro Robotic Platform. So, see, it is this website is a part of Blue Brain project. In this, they are working on the development of a human brain, and it is one part, and it is more related to the means integration of your robotic and neuro robotic. So if you will explore this, and I will show some of the ready to use models are there. See, for this you have to create one online account, okay, in which they will give you a specific login ID, and inside that you are able to create a different experiment related to robot and related to neuro robotic. Okay, just give me 1 minute and I will show some document. See, once you will get inside that online portal, and after getting the login, and so this type of environment uh, is with you. Okay, so here you can see one robot is there, and type of a environment is there, and means inside a room one blue screen is there, and over a screen some object is there. And so this robot is initially blank, and we have to write a rules and some kind of functionality in the brain of that robot, and then we have to run that environment. Okay, so see after this, see this is a case of humanoid robot, and the same or similar kind of functionality we can also provide inside this wheeled robot, and having the 4 wheels and 2 screen is there. So type of scenario we can create, and different scenario we can create inside this environment. Okay, we can change the color of screens, and so accordingly your robot will take decision. But these rules we have to write inside the brain of that robot. Okay, so see different type of robots are there inside. Okay, inside this you can also get this rat experiment. So these are the same screenshot from inside the login of that platform. We can also able to change the colors of these screen, and so accordingly this virtual rat will take the decision. And we can also able to change the color from red to blue, blue to red. And little coding you have to do. Okay, and you can easily able to see plot the activities. Okay, and these are the, you can say, the body parts of the means variation in the position and the velocity, and how your robot is moving in that environment. And this is the main thing, and neural signals inside the robot. And so you can see like here 1, 2, 3, 4, 5, 7 neurons are there, and out of 7 neurons the recording that is totally black or gray means these neurons are active at that time, and others are at the rest position. This we can analyze inside the neural spikes. So this is a type of means Python language you can do inside that platform. For creation of a scenario, and one more thing I will show to you. Here you can see when both these screens are red, so robot is not able to choose in which direction he has to move. And once we converted that screen color and change that screen color to blue, So then your robot is moving towards the blue screen. And again, when both these screens are red, so still your robot is trying to identify where is the blue screen. And then it is moving towards the blue screen. Okay, so this type of scenario you can also make, and it is very easy. And though see
these different these schedule signals of different frequency, and how we are going to do that sum, that will be some weighted sum. Okay, हर एक signal का in this signal, in actual signal, there will be weight of this low frequency signal, and then there will be weight of this high frequency signal. Okay, so that much is covered by the Fourier. We can represent this with the help of like this. That was a mathematical formulation for it. Ft can be represented as summation of
please
minus
mute somebody, some participants mic is on, please.
to the power j, pi, and capital T and small t. This was the formulation where j is equal to minus 1. Okay. Cn is the coefficient over here. Cn is Ft e to the power j minus j 2 pi and t dt. Okay, don't worry for these formulations. These are this. I'm writing for this for the representation, and we will see the actual formula which we need to use.
Okay, so that is all from my side, and if you want to explore this website, and I will just give you the link.
E is equal to j theta is equal to
I will just give you the link. Yes, you will explore this platform. Okay, and try to use some of the neuro robotics model in your IoT field. Okay, so still few minutes are remaining. Now, so if some participant want to ask something, then please ask.